So let's go ahead and jump in to the notes for today. So we've been going over things like the states of matter, solids and liquids, and how we change in between those. We've looked at what happens when we heat up matter over time, right? So that heating curve was all about what sort of changes go on in matter when it gets heated up or cooled down. So today we're going to be shifting gears a little bit, still talking about matter, but instead of just talking about properties of solids, liquids, and gases, we're going to be talking about properties of all the different kind of characteristics of matter. And we're going to describe a little bit how to go, or kind of what the differences are between different types of properties and changes for this matter. So there's kind of four major categories of things that we're going to look at today. And so there's four sort of major categories that you guys will have for your daily assignments for today and tomorrow, Friday. So we can split things up by whether or not it is a physical property, if it is a physical change, if it is a chemical change, or if it is a chemical property. So I'm going to be going through these one by one and kind of providing you guys some examples of each one as we go along to sort of help you cement it in your brain. What do we mean when we talk about a physical property versus a chemical change? Stuff kind of like that. So first up, we have physical properties of matter. So a physical property of a piece of matter is a characteristic, so a description of a substance that can be observed without changing its identity. So if you guys remember back to the first week of class, we talked a little bit about observations and how you can use all five of your senses to make observations. So physical properties are things that you can observe about a piece of matter. So things like measurements are observations. So how heavy something is, what its mass is, how large something is, so its dimensions, if you wanted and measured its dimensions. The color, so we talked about color as a really good example of an observation you can make about an object. So physical properties are just things that you can observe about objects, specifically without changing what you are observing. So a little bit later on, we'll talk about what we call it when something changes from one form, one type of substance to another. But right now, we're just focusing on physical properties, which means the matter, the chemicals that we're looking at essentially are not changing. They're staying the same. So we can use physical properties to separate objects that are mixed together. So for example, if you want to separate things based on color, like if you have a whole bunch of blocks and you want to put the purple ones over here and the blue ones over here and the green ones over here, the color of those blocks is a physical property. If you want to separate something based on its size, right? So like when you're making coffee in the morning, you have all those coffee grounds that are sitting in that filter paper, and the coffee filter, the paper in it, the holes in the paper are big enough to let the water and the flavor compounds from the coffee through, but they're not big enough for the ground up coffee beans to go through themselves. So the size of molecules of water and coffee flavor and coffee beans are different. So we're able to separate them out based on that size. The state that matter is in is also one of its physical properties. So if we're looking at an ice block versus a bunch of water in a pot, whether or not it is a solid or a liquid is a physical property, is something that we can describe by observing that object. So whether or not it's a solid, liquid, or a gas, what color it is, how heavy it is, what size it is, if it is really bendable, or if it's really brittle, it'll snap in half. All these things that you can observe, so you can either look at something or touch something or smell something about this object or measure something. Anything that you can use to describe how an object looks and feels and behaves is a physical property. So, for example, water, one of its physical properties is not only whether or not we're looking at solid water or liquid water, but also what temperature that it freezes at. So, for example, in water, one of its properties is that it freezes at 0 degrees Celsius, kind of like what we talked about on Tuesday with our heating graph. We go from solid to liquid or from liquid to solid water at 0 degrees Celsius. So where something freezes and melts and boils and condenses, that's one of its physical properties. All right, metal is very hard, right? It's hard to squish and bend, and it tends to be really heavy. So even if you have a small chunk of metal, it's very dense and very heavy. Again, a physical property, something that we can determine by looking and measuring this metal. This plastic water bottle down here is made out of thin, clear plastic, so it's see-through, right? You can see to the table underneath the water bottle. And this, unlike the metal, is pretty easy to squish and bend around, right? You can take a water bottle and smush it down flat. It's very squishable. So that is one of the physical properties of the water bottle. And then if you have some fruit or like some old nasty bread or something that's been sitting in the cupboard for too long, then it's gonna look nasty. It's gonna have this mold on it. It might be starting to turn green and black, and it'll smell bad and taste bad. Those are physical properties of rotten fruit. Those are things that you can observe that will tell you, oh, this is not good anymore. I should stop eating this. Or man, I really should have put those in the fridge when I got home. Whoops-a-daisy, oh well. So all these physical properties, things that we can physically observe and measure about matter, about stuff in the universe. So when we take some matter and change up how it looks, say we do squish down this water bottle really small, or we break this big sheet of metal into a bunch of chunks and pieces, when that happens, it goes through something called a physical change. So the most important thing to keep in mind when we're talking about physical changes is that we're changing the form of a substance. So we're changing what it looks like without changing its identity. We're not turning it into something new. It is staying the same. It just looks different than it did a little bit ago. So the properties of that matter remain the same, right? If you take a plastic bottle and you smush it down until it's almost flat, it's still made out of plastic. It's still clear and mostly see-through. You could still unsquish it and stretch it back out. So we haven't turned it into some new chemical or some new object, right? We didn't squish down this plastic bottle and that turned it into metal all of a sudden. It's still plastic. It just went through a physical change. So you start with something, you end with the same thing. It just maybe looks a little bit different. So going through a phase change, so we talked all about phase changes on Tuesday, about melting and freezing and sublimation and condensing. All of those are physical changes, because even though we're going from solid to liquid or liquid to gas, despite all of that, it's still water, or it's still carbon dioxide if you have dry ice. It just changed from one state to another. So it looks different, but it has the same identity, right? So if you have a whole bunch of dry ice, which is those frozen solid carbon dioxide blocks, and then you just sit them out in the open air and they start giving off gas, that CO2 is going through a physical change from solid to gas. It's still CO2. It's still CO2 gas that you see coming off and kind of looks like fog or mist. But it just looks different now than it used to. Same thing with dissolving. So if you sprinkle some sugar in your coffee in the morning, it looks like it disappears, right? If your coffee was clear, or if you had like some hot water and you were adding sugar to it, you stir it around and it looks like the sugar disappears. But if you taste the coffee or you taste the water, it tastes sweet. You can still taste the sugar in it. That's because the sugar isn't gone. It didn't get changed into something else. It just got physically changed from a big sugar crystal that you could see into a tiny microscopic sugar crystal that's invisible to our eyes, but is still sugar. It's still floating around in your coffee as sugar. It just went from a big crystal of sugar to a tiny microscopic sugar crystal. We started with sugar, we dissolved it, we still have sugar, it just went through a physical change. It looks different, its form is different than what it used to be. Same thing with like grinding or shredding. So if you take a piece of paper and you tear it up into 100 pieces, those pieces are all still made out of paper, right? You have a ton of paper pieces all on the ground now. You just went from one full sheet to a whole bunch of shredded paper. So that is still a physical change. We started with paper, we ended with paper. The paper just looks a little bit different now than it used to. So some other examples, putting wood through like a wood chipper. So we have these big logs, these big trees. We stick them through these grinding blades of this wood chipper and it spits out sawdust up here at the top, spits out these tiny wooden chunks. This is still wood that is coming out of the end of this wood chipper. We haven't turned the wood into some new chemical or some new compound. It went in as wood, it's coming out as wood. It just happened to go in as one big solid piece of wood, and now it's coming out as millions of tiny flecks of wood. So this is a physical change. The wood looks different over here than the branches going in over here, but it's still the same object. Same thing like I talked about earlier, if you have a pot of water on the stove and you crank up the heat and it starts boiling and the water seems like it's getting lower and lower in your stove because more and more water vapor comes out, you're just physically changing the water from liquid form to gas form. It's still water, it's still H2O, but it was a liquid and now it is a gas. And then, like I mentioned before, dissolving. So if you put some salt or some sugar into a liquid like water, stir around for a little while, the salt is still there, it's still in the glass, right? If you let all the water evaporate or boil out of the glass, you'd have a bunch of salt left over in the bottom. So the salt doesn't change into something new. It doesn't become vinegar all of a sudden or raisins somehow. It just goes from being these big white salt crystals that you can see to tiny little microscopic salt crystals that are floating around in the water. The salt's still there, right? Like, I don't know if anybody when they were younger and they were sick and they had a sore throat and your mom made you gargle salt water to help. Terrible, awful, I hated it. It was disgusting. But the reason the water tasted so gross is because the salt was still in it. It was still present. It just, I couldn't see it anymore because its physical shape had been changed. So that is physical properties and changes. Things that we can observe and measure about a substance, and then we can change that substance into being a different form but as long as it stays the same chemical, the same object, it is a physical change. Now, what if we start off with one chemical, one set of matter, and we end up with something new, something different? We don't have a physical change anymore. Instead, what just happened is a chemical change. We have chemically changed our matter, our substance, from one thing to something very different. So we have changed the identity of a substance. We've created a new set of chemicals from our old set. This means that the properties of this chemical have changed. So maybe it is a different color now, or maybe it's more reactive to other chemicals. Whatever it is, since we don't have the same stuff to start and end with, we don't have the same properties either. They change from beginning to end. So there are a couple different kind of signals that might tell you that a chemical change is going on. So a color change, and I don't mean that when you soak coffee beans in water, the water turns brown. That's not the kind of color change that we're talking about. We're talking about if you're mixing liquids together and you mix two colorless liquids and all of a sudden purple shows up in your beaker. That
Mr. Stanley?
Change would indicate that a chemical change is going on.
Mr. Stanley?
Yeah.
Would bleach be an example of chemical change?
You mean like when you put bleach onto a surface?
Or onto a piece of clothing or something like that, because it does change the color and not be put back to the original color unless you add like a dye or something.
Exactly. So the reason that color comes out when the bleach touches it is because the bleach causes a chemical change to happen in the fabric, and that results in the color of that fabric changing. Same thing with the reason why it's good to use bleach to disinfect stuff. Like if something got really gross and you really want to make sure that it doesn't have any bacteria or viruses anymore, bleach will cause chemical reactions in those microorganisms that cause them to like disintegrate and totally break down, essentially. And so those would be chemical changes that happen at that microscopic level. So yes, that is a great example. Bleach hitting your clothes causes a color change due to a chemical change, a chemical reaction. If you have a new gas or a solid that gets formed, so like for example, in the old school science fair experiment of mixing the baking soda and the vinegar and the volcano, and then all that stuff comes out the top, that's because when you mix baking soda and vinegar, it forms a new gas that didn't used to be there presently. So this is not like what we talked about earlier, boiling something to turn it from liquid to gas. That's going through boiling, that's a physical change. A chemical change is when you mix different chemicals and the chemical reaction causes a new substance to form that is naturally a gas. So that's why you get that big explosion of the baking powder and the vinegar, is because those two things chemically react with one another and create a new gaseous substance that starts coming out the top of your volcano. If you have a reaction that produces a lot of light or heat, that's because a chemical change is going on. So we don't get these a lot down in Texas because you don't really need them. But when I lived up in Ohio, I would get the little hand warmers, which are, if you've never seen them before, they're these little packets that you're ready to use them. You crinkle them up and then put them in your gloves. And when you crinkle them, you cause two chemicals to come into contact with each other, and they go through a chemical change that results in heat being given off. So it's a good way when it's like 7 degrees outside and you've still got to go to school or go to work. You put those in your gloves and they help your hands stay warm because the chemical change inside of those little packets is giving off a whole bunch of heat. So some other good examples of chemical changes that you might see every day are things burning or combusting. So in your car, for example, right, you put gasoline into the gas tank and then you start it up and your car burns gasoline in order to make the wheels turn and go forward. When you burn gasoline, not only do you create a lot of heat coming out of your engine, but you hopefully don't have gasoline coming out of your exhaust hose in the back, right? If you've got gasoline coming out of your exhaust tube, you've got a really big problem. What should be coming out of there are things like water, carbon dioxide gas, and carbon monoxide gas. And that's because when you burn gasoline in your engine, the combustion causes that gasoline, to turn into these new different chemicals that we then get rid of through the exhaust system of your car. Rusting is another example of a chemical change. So you leave like your bike outside over the years and the chain starts to get all rusted on it. At least that's what happened to my bike in college because it was outside all the time. The rusting happens because the iron in the metal that's inside the bike is slowly reacting over time to the oxygen and the water that's in the air around us every day. And when the iron and the oxygen react with one another for a long time, they start to form a new chemical called iron oxide, which has that brown flaky look that tells you that something is starting to rust and isn't really going to work that great anymore. So again, things like burning, so not even necessarily combustion, but when we burn firewood, like if we're making a big fire, we have a lot of light coming out of there and a lot of heat, and the logs that we put into the fire are combining with the heat and the oxygen to produce carbon dioxide gas, which goes up into the air as smoke, and then the ash that's left over after the fire. So the ash and the logs are different sets of chemicals. They have gone through a chemical change in order to create that ash. I mentioned rust earlier, so all of this brown stuff on this chain right here is iron oxide. So the iron has chemically changed into this new compound. So normally, like we talked about earlier, some of the physical properties of metal are that it's shiny, a lot of times it's silver, and it's very strong. Iron oxide, on the other hand, is very brittle and flaky, and it's this brown color. So we have a color change, and we have a change of properties, which means that a chemical change has gone on. One other good example of a chemical change is things like Alka-Seltzer tablets. So when you're feeling sick or your stomach's not feeling so great, and you drop one of these tablets in water, it starts fizzing like crazy, right? That's not because the tablet caused the water to start boiling all of a sudden, but instead the water and the tablet are reacting together and giving off a new compound, which comes off the tablet in the form of the gas, which is what forms all these little gas bubbles down here in this glass of water. And so we have gas formation, not due to boiling, like we talked about on Tuesday, but due to a chemical reaction producing a new chemical that comes out of the water as gas. So the final thing that we're going to cover today is chemical properties. So if physical properties tell us about different traits and attributes that a substance has in terms of its appearance or its feel or its state, chemical properties tell us essentially how likely a substance is going to undergo a certain type of chemical change. So we talked about burning, we talked about rusting. There's also reactivity. So how likely is a chemical likely to react with air or water and go through a reaction with other chemicals? These are all chemical properties of objects. So, for example, things like wood, gasoline, kerosene, they are all very flammable, right? It's pretty easy to light them on fire. But things like plastic or metal or rubber, they have a much lower flammability. It's really hard to get plastic to light on fire. And so how easy it is for something to light on fire is one of its chemical properties. Same thing with reactivity. So this is just how likely is something to go through a chemical reaction or a chemical change with other substances. So some stuff like the mineral potassium, for example, that is very reactive. It's very likely to go through a chemical reaction with other atoms, other elements. But something like neon gas, so like the cool neon signs that you see on the front of stores and clubs and stuff like that, the neon in those signs is very, very unreactive. The neon does not want to react with other chemicals. It just wants to stay as neon gas, and that is it. So how likely that something is to go through a certain chemical change is its chemical properties. So to recap, chemical change is when we have substances that start as one set of matter, one chemical, and then change into something different, something new. And a chemical property just tells us how likely is something to go through that change. Is it very likely that it's going to go through a certain chemical change, or is it very unlikely? And then to recap, back to the beginning, physical properties, things you can observe and measure about objects, and then physical changes are when an object changes its form, it changes how it looks, but it's still the same substance. It's still the same matter at the start to the end, like tearing up a piece of paper, for example. All right, any questions on physical or chemical properties or changes so far? Anything that you want me to go back over or review in a little more detail?
These are the same notes that are on the PDF, right?
Mm-hmm. Yeah, these are the exact same notes that are on the Google Classroom.
Okay.
So yeah, you can go back and look at these at any time you want, especially when you're going through the homework for today and tomorrow. You might find them to be really useful. And then also, I'm recording me going through these notes right now, and then I'll post this recording on our Google Classroom once we've finished here today.
Okay.
All right, so speaking of the homework for today and tomorrow, let's take a look at what that looks like. So like I said, you guys can get to these exact same notes yourself if you go to our Google Classroom, and this is under today, September 10th, Thursday, chemical and physical properties and changes. So the homework for today and tomorrow is kind of two sides of the same assignment. So for the first set of homework that is due today, The very first part of it asks you about a piece of wood. So just imagine like a stick or a log like this one, and write down what are 3 physical properties that you think could go with a piece of wood, as well as 1 chemical property that you think fits with it. So this is what the Google Doc version of this assignment looks like. The Google Form version looks a little bit different, but it has the same questions on it. You'll just record your answers about the piece of wood on these first 2 questions. I'm sorry I wasn't able to get this very fancy log drawing to go onto the Google form. So that's the first part. That should not be too difficult. The second part, and kind of the main part of the worksheet, gives you 10 of these properties down here about glass or iron or diamonds or ice. And it asks you to tell me if each of these properties is a chemical property or a physical property. And you can do that by writing down, I might not let you fix that. You can do that by writing down C or a P for each one of these questions. So C meaning that you think this describes a chemical property, and P meaning you think this describes a physical property. On the Google Form version, the one that looks like this, it's set up a tiny bit differently, but it's essentially the same thing. So for each one of the same properties, you just have to mark in the box whether you think it is a chemical property or a physical property. And you'll go through and do that for each one of the properties. So that is the daily assignment for today, making 3 physical properties and 1 chemical property for a piece of wood, and then classifying those 10 descriptions as being either physical or chemical properties. The assignment for tomorrow is extremely similar. So it's not posted for you guys yet. It'll post at midnight tonight. And again, make sure you do this tomorrow so that you can get your attendance credit, since we don't have Zoom class. It's basically the exact same thing, only now, instead of classifying properties, you're classifying chemical and physical changes. So it's basically the same setup. We have, in this case, a series of 18 descriptions. And for each one, you're gonna, again, write if it is a physical change that is being described, or if it is a chemical change that is being described. And then just like with the Google form for the properties, the changes is set up in the same way, where for each change, you'll just mark down whether or not you think that is describing a chemical change or a physical change. All right, and that is pretty much everything that I have to share with you guys today. Does anybody have any final questions about physical properties, chemical properties, physical changes, chemical changes, or the assignments that are due today and tomorrow? Any changes about anything we've talked about today?
No, everything's kind of helpful. Well, it is. It's basically right in front of our eyes.
All right. Well, if you ever do have any questions, please remember that you can always reach out to me by texting me or emailing me or writing down a comment on the Google Classroom. being like, hey, I'm having trouble with this assignment or with these notes, and I'll do my best to get back to you as soon as I see it. You can try calling me if you really want, but usually I'm in the middle of working on something for this class or for a different class, and so I might be able to answer your call and walk you through stuff right there. But you can also always, if you want to set up a Zoom time or a phone call with me and have me talk you through some of the different situations, then you're more than welcome to do that as well. Anything that you guys are getting stuck with or having trouble with, I am here to help you out. It is literally my job to do that.
Okay.
All right, let me go ahead and stop our recording here.